Okay,
All
you were
right.
live.
Yep. Hi. Thank you so much, everybody, for joining. So welcome to the Empowering AI Agent Protocols with TSP and First Person Credentials presentation. We have a very exciting following hour. And yes, I want to talk to you about our current presenters as well. So first of all, this presentation is being driven by the Trust over IP project. This is a key project initiative under the Linux Foundation Decentralized Trust. And Trust over IP is dedicated to developing a robust interoperable framework for internet scale digital trust. And just a little bit of background, this community is bringing together global experts to establish open standards and architecture that enable trusted digital interactions across individuals, organizations, companies, and technologies. So I'm pretty sure maybe some of you might be already familiar with this project, but if not, I really suggest that you look into our LF Decentralized Trust page for more information. So yes, so today we have two presenters. We have first Wenjing Chu. He's the Senior Director of Technology Strategy in Futurewei Technologies, and he's also the co-chair of the Trust Spanning Protocol Task Force in Trust over IP and maintainer of the Trust Spanning Protocol in the Open Wallet project. He's also the chair of the AI and Human Trust Working Group in Trust over IP. He's going to lead the conversation about what is Trust Spanning Protocol and how they empower AI agent protocols. And after that, we have another presentation by Drummond. So he's the co-organizer of the First Person project, and he's also a steering committee member of Trust over IP and co-chair of Trust over IP Technology Stack Working Group, Concepts and Terminology Working Group, and the Centralized Trust Graph Working Group. So he's going to help us with an introduction of the First Person project and the centralized trust graph. So after that, we'll give it maybe 10 minutes or the remaining time in the presentation for any questions and answers. And in the meantime, if you have any questions, feel free to post in the meeting chat, or if you're watching in the live stream in YouTube, feel free to post your questions there, and we will do our best to track them and bring them to the attention of our presenters. So with that, I want to give it the floor to Wenjing Cho. Thank you, Wenjing.
All right, thank you. And I'm honored to be here. Um, so the talk is going to be two-part. I will go first, and then Drummond would continue on discussing really what the first person project, but also how that would enable AI agents. So my portion, let me put my slide on. Um, Let me get the okay, hope that's better. So I'm gonna start with a couple of things. Trust spanning protocol, mostly the ideas behind it and its major functions. I saw a lot of people that I probably met the first time in this talk, so I want to make sure that I cover what TSP really is. And then we will go into a little bit about how this protocol really makes the task of building trust relationships, give personhood credentials, give credentials to AI agents, etc., a lot easier. And then we'll see how this can apply to agent protocols and potentially your own work as well. So I will try to do that in the about 20 minutes or so that we will break before the half-hour point for Drummond. Okay, so a simple way to really talk about TSP is our design principles and motivations. This work started a few years back, so it's been a while. But I want to basically revisit these basic ideas about trust spanning protocol. And the approach we've taken is, really going back to how the original internet architecture was designed and to take a very principled layered approach. And so the two layers we're going to most focus about in today is trust tasks at over TSP. And so the TSP will be the lower layer that providing probability, and the trust task will then be built on top of it so that you would be able to get, for example, very good and long-term trust relationship management over a protocol that solves the basic problems. So make the overall solution a lot cleaner and easier. And some of the key, I think, support we want to provide is a long-term verifiable identities. We'll get into that. And also that allows us to support reputation, or really what we, I think more broadly speaking as a trust relationship. In order to do that, I think the basic features we decided that should be included in the TSP are uncompromised authenticity and non-repudiation. So this is basically we summarize into who said what to whom. And so that gives us the authenticity I think we're going to need for this level of trust. And the second area that the trust spanning protocol provides is privacy and metadata privacy. And those are optional, depending on what kind of application you're building, whether this level of privacy support are warranted. Okay, so come back to the TSP and why this is important, I think, for AI agents, specifically even more into the protocols that the AI agents speak. The basic, I think, problem, I think most of the internet applications and now AI agents have problem with is the so-called web stack, which is really showing a lot of limitations. And I think in this group, you probably already know, but I want to basically say that the status quo, as what normally says as best practice for such software stack aren't good enough. And AI agents really mix a lot of the basic assumptions about web stacks own security and privacy guarantees very problematic. So we've talked quite a bit about in the past about trust versus security, and I want to use more and more the language of trust versus security. I will, explain that term a little bit as we go along. And so what we then decide to do is to take these design principles to build a trust spanning protocol. Essentially, it's a trust relationship in the internet, but it's a spanning protocol, so it allows interoperability across the internet rather than a specific small domain. Some of the, I think, goals we want to achieve are minimalism, have very good efficiency, so can apply in any applications, and provide sufficient flexibility and agility for cryptographic algorithms as we go along. So those are the goals. And we have been working on this for quite a while, so I will just put two links here. One is the spec itself in trust over IP, and the second bullet is a experimental software open source implementation for the SDK. And from there, you will find some of the applications we built around that as well. So, all right. So let me see our time. And I want to then quickly cover the main features, and then we get into the applications. So the main features we want to cover start with really what the TSP is trying to do. It's trying to establish and manage directional trust relationships between endpoints. And the endpoints are identified with verifiable identifiers. So in the beginning of all of that is this first diagram with two circles, and there's a arrow going from left to right, and TSP message going over some kind of transport, right? And So the first thing we need to do is then we want to define this endpoint, what exactly mean. And technical terms is a locus of control. So this is really coming down to how you build your endpoint, where security of that endpoint is, how much the user or the person in control of it have ability to exercise control. So this shouldn't be too hard to map into actual practical implementations over this, but that's the concept we go with of the so-called wallet and endpoints. And from there, we introduce verifiable identifiers. The example I go with throughout this presentation is DID Web VH. VH stands for verifiable history. And so this is in a DID format. It doesn't have to be in a DID format, but it need to be something that is giving you a verifiability. And specifically, I think not just the sort of natural key pairs, but also how you manage the key pair, because we want a long-term identifier in order to support long-term relationships, that the identifier need to be able to do very good, for example, key rotation and other features. And so the WebVH is the first example we use to show you that how such an identifier could give us the ability for verification of the authenticity of the identifier, but also throughout the history. So it gets stronger and also flexible to use. And you can use the identifier itself in the long run. So here's a little bit more example of going into sort of how the mapping works in a very simple term. It's really a self-certifying identifier itself, which is the blue portion that can be mapped into and followed by the red portion is really about where you may find the information, and so that portion can be then mapped into a URL. So the verification is really rely on the information or the history information in the URL, both in terms of what the document or what the data is, but also the history of that identifier. So both of them are then tied to the SCID, the self-certifying identifier, the blue portion here. Okay, so I won't have time to go into deep, but those are, if you search for the WebVH presentation, there are quite a bit that we've done, or the group working on WebVH has done in the past. So that gives us two endpoints and a mean to connect from one to the other. And so the second level of function is the messages. So messages include a envelope payload signature feature, and then additional features to support the metadata privacy. So combined together, we usually summarize the features as these 3 points: authenticity, confidentiality, and then metadata privacy. I'm going to go over each one of them now. And so the message itself goes from A to B, and that is over some kind of a transport. And this is really the encoding and as the encryption and signature portion, how they come together. A overall scheme is called ESSR. So we encrypt the sender's identifier, which is here is represented by the VID sender on the top right. And you then sign the whole message, including the receiver. So that's the ESSR means it's encrypting the sender and sign receiver. And the reasons for doing this is really for us to go beyond encryption, beyond the general issues of protecting and for disclosures or any kind of security breaches on the endpoints. It's entirely asymmetric in the algorithm it uses. So that's we won't be able to go into those details here either. But this is, this diagram just to show you how the message itself is composed, and this is what are going between A and B. The claim we want to make here is that this gives us the both authenticity and confidentiality. So the authenticity specifically goes into who said what to whom. That is the identifier of the sender and receiver individually, but also the direction the message is going. The second, of course, is the confidentiality, which is based on the hybrid public key encryption, or HPKE, that currently a form of that is being standardized in IETF. We also support an earlier version of the similar algorithm called sealed box that's very highly available in open source code. And work is ongoing for providing the PQC support for natively in TSP as well. We're waiting for the final I think the maturity of implementation for that. Currently, the code has been embedded in the protocol already, but it's experimental. So you could do early testing, but the algorithm itself, I think we're waiting for those code to become mature. All right. So in summary, these messages give us a bidirectional relationship, a pair of unidirectional relations. So you basically have one direction and you do exactly the same on the other. And the two are stitched together on the two endpoints as in your wallet. So the relationship itself is maintained in the wallet. All right. I'm going to very quickly go to the second point beyond authenticity and confidentiality is the metadata privacy or privacy portion. So metadata privacy refers to the problem in the internet that people can, or there are many ways that you could observe what's going on and learning from the metadata or the headers of HTTP, TCP, IP, etc. Additional information is really on the internet that can be observed. All of these would provide a very good portrait of the communication going on, and a lot of times can discover a lot of information. So what can we do about it to at least mediate this particular problem? And we introduced two components for this. One is nested messages, is essentially sending a message, a TSP message within another TSP message. So there will be two relationships here in that diagram showing as A to B and A1 to B1. I won't go into too much detail, but this is a encoding scheme that we have defined efficiently to allow this to happen. So you logically would see it as a message is going embedding inside another message. The second, which rely on the embedded messages, is a routed message. So here's a diagram that let's say this potential topology here, and I guess a easy combinational approach would be like, hey, between A and B, you can potentially go through, well, at least the four, but potentially depend on using one or two intermediaries, you could have probably more of those. So the precise route of this message hidden because we introduced the embedded message allow us to hide within. So the first thing is that you could then establish relationships from the endpoint A to intermediary P, and similarly from B to Q, and therefore route through by hops. And that's shown in the gray, thick gray line. So this thick gray line then presents a higher level relationship from A to B directly. And then through another level of embedding or nesting, the thin blue line will then be hid within that gray line. So the end result is that A and B would be able to be communication hidden from third parties, and with very limited information leaked to the intermediary. So that's the very high level summary of the features for embedded messages. I'm going to skip very quickly the encoding portion now so I can capture how this would help agents. The encoding, we typically call Caesar encoding, give both binary and text modes. This is always aligned. So it's a way to do efficient but still also text-based communication. The overall scheme is self-describing. It's very efficient for cryptographic primitives. And the efficiency comes really if you think about the round trip you will have to go deal with when you have a format such as JSON and do let's say encrypted signatures and ciphertext, but then embedding again into another payload. So this round trip really is very costly. So the Caesar encoding, which is a separate specification, really deal deep into these problems. And so that's the encoding we use for TSP, for all the header signature, all the things you see earlier. The payload itself can be anything. So the Caesar encoding allows you to mix or combine other data components that's in different data formats. So we believe this is really the best approach for a spanning protocol like a TSP to do. All right, so I'm going to just skip the overall reference framework from here so I can speed up a little bit. So this is the diagram we've been showing, just more formalized. And again, re-emphasizing the layered approach. And we've currently been talking about TCP, the trust spanning layer. And the trust tasks are what we think of, personhood credentials or AI agents, and we're going to get into that. So what TSP can help? More specifically, I think these personhood credentials and AI agents. And on the credential side, I'm going to leave mostly Drummond to speak to that in more detail. So here's an example of the Linux kernel project about really both security and trust, but in who is really the legit open source contributor or maintainer in the system, who they are, right? Understanding where that software coming from. We've looked into how this could be implemented through a TSP-based trust task. And so in here are two examples of the lower layer as a trust spanning protocol, and then higher layer with different kinds of credentials, and allow those credentials to come together to give the actual personhood or the kernel group is looking for. And again, Drummond's going to go a lot more detail into this, so I'm going to skip quickly. And in the end, the software would show up as the left portion in some kind of a personal endpoint. So that could be your mobile phone, for example. And on the right side, we'll then have a way to deal with the Git and Git platforms and integrate into that platform. So I won't be able to go into quite more detail here, but you will see in later examples how the software works. I'm going to skip all of this as well quickly to jump into the AI agent protocol over TSP. So we mentioned the AI agents, and that's currently based on very traditional HTTPS and OAuth, and OpenID, for example. Those are the standard solutions for agent protocols, just like any other web-based applications. And I'm just going to in general refer them as the web stack. We've been starting to working on then giving the AI agent protocols to use TSP and to solve some of the problems. And when we do that, we'll put a label, a letter T in front of it to say TMCP, just so that we distinguish the two different flavors. They are really the same protocol. It's just that the security layer and the underneath protocol have been changed. The MCP protocol itself remain the same. Very quickly, the mobile context protocol, a model context protocol, really give it AI agents or agent-based applications a way to deal with information tools, databases, and many things. So I won't go too much into here. There's a survey paper included in this slide that goes about very different type of these protocols and how they do things similarly, and areas to being different. We pick MCP as an example because it's really taking a lot of interest to a lot of the application builders. And I'm providing another link sort of to point you to more detailed description of where the security and trust problems the agents are facing today. And then why I think the TSP can help there. But we'll provide a simpler version here. The basic problem, I think, where we think that best practice are insufficient is because most of the web stack talk about security, where they are introducing a party that is hidden in the overall system. And these systems, we think that will not be able to hold or help the trust between the two primary parties here. And so are we really ready to hand, AI agents, the keys, your wallets, payment decisions, all that to the automated AI agents? And that's the big question. I think there's a lot of things lacking, and the goals itself is misaligned. And so those are problems that traditional centralized security models will not be able to solve. Now I'm going to a little bit on the approach we're taking. So the approach really can be shown in this picture on the left, from left to the right. And you can see from the left side, the MCP messages are going over JSON RPC, which goes into a transport. We are simply designing the transport in a way so that the TSP will show up as a transport for this protocol. Not shown here, of course, are the wallets, which need to be representing or be embedded in the agent itself. And so that we have the wallet, and then TSP provides the transport for them. The end result of doing all of this is that, this slide shows the example of how a very simple agent protocol would work with the TMCP, with the TSP running as the security and trust layer. So all of that detail of the use of a TSP can be built in the SDK itself. So from here, we're changing from a fast MCP to TMCP. And then the instantiation of the two entities are about the same, look very similar, with the one exception that the name, is not just a arbitrary string, but the name gives you a unique app identifier. And so, for instance, you can create a namespace for yourself, and that namespace will be unique, and you can link or bound that namespace to the verifiable identifier we talk about, and link that together in the wallet. All the proofs, everything work the same we introduced earlier in the TSP. We did the same thing for A2A protocol, and the A2A protocol goes into, highlight the three portions really, both the so-called API key, but more interestingly, the agent card both of them then can be a credential or a information that's linked to the verifiable identifier for the agent. And then the A2A server operation then becomes a TSP based or TA2A server operation. And the rest of the functionality and for the application developer point of view look very much the same. I want to just summarize. This is a very simple thing to do, and a lot of people are working on more and more applications that can apply TSP to their trust tasks. We have more examples in the Open Wallet TSP project GitHub that includes a lot of the more of agent applications as well. So I won't have time to go into those details, but I will point those links to you. Okay, so in summary, this method of applying TSP to trust tasks is very general. It simply gives you a way to identify some software entity with a verifiable identifiers that give you a known way of using the wallet or how to protect those information. And finally, TSP give you a transportation or messaging layer, allow the two sides to have trusted messages. This trust model is easy to adopt, very compatible. The messages are asymmetric, and you can tune or adopt what kind of encoding schemes you want to use for your application sort of seamlessly on top of TSP. So again, complex, challenging trust functions are a lot easier to implement and to be correct and to be interoperable. So those are, I think, the benefit of doing this. All right, so I'm going to stop here so that I don't overrun too much of my time.
Thank
And
you, Wenjing.
yeah, I'm
Thank you
going to
so
stop
much. And
sharing. Yeah, go ahead.
yes, and we have um, we have three conversations going on earlier while your presentation um, was happening. So thank you, Drummond, for replying to those. But just pretty quick before Drummond's presentation, is there any outstanding questions on Wenjing's presentation? Please feel free to raise your hand if there is. And if not, there's always an opportunity at the end of Drummond's presentation for any more questions. All right. All right. Thank you so much. And now let's go and give the floor to Drummond. Drummond is going to be presenting an introduction of first person project and the centralized trust graph. So go ahead, Drummond. Thank you so much.
All right, I'm bringing this up. Is this displaying properly?
Yes, it is.
Good, very good. All right, so it's always a pleasure to go after Wenjing because he explains all the hard stuff, and I get to talk about the easier stuff because you can think of the first person project, what we're doing as working right on top. It is a set of trust tasks on top of TSP, as he just explained it. And so I'm going to talk more to, okay, what's the problem we're solving and how are we doing that and how does that apply to AI agents? And I'm going to try and do that relatively quickly. I'm going to start out with best way to introduce this is the way that Jim Zemlin on this picture. This is taken from the Linux Foundation Member Trust Summit last March. And Jim did his whole presentation on the first person project, why the Linux Foundation needs it, and actually wants to start with the Linux kernel. He explained that the XE attack, one of the malware injection attacks, came the closest to being one of the worst security incidences for the internet, and it was only discovered by a very vigilant Microsoft developer who noticed the problem and caught it before it had widely spread. This is the QR code there is to the Wired magazine article about it if you're not familiar with it. Jim said, hey, this is a really good illustration. There's other reasons we need decentralized trust systems, and that is the increasing use of AI in coding, AI bots actually making pull requests, and the fact that you need for provenance and the SBOM for an open source project to be able to say what came from whom and which was human contributions, which were agent contributions. So he then explained the first person project is directly aimed at that, solving the proof of personhood problem. And he cites the same paper that he cited from slides that we provided him to explain it to him. I'll talk more about that slide later. He then said, why should we start with open source projects? Why should we go first in the adoption of first person credentials? And you can see this. I took all these just pictures of his slides from the sitting in the front row. Open source supply chains are critical to defend from these kinds of attacks and to maintain trust in, because the whole of the open source movement depends on being able to maintain that trust in those projects. And he finishes with a slide that makes our point. Well, we're after the first person project. We're going to deal with the interoperability challenges of SSI and verifiable credentials by basically saying, hey, for this set of credentials, we need this specific support in wallets. We need these two types of credentials to be supported, and the ZKP presentation, and we need the ecosystems to provide the governance that makes it all work. And as we start to build that out, it has a network effect that as of yet we haven't achieved with SSI and verifiable credentials. So that's what we're all about. So in a nutshell, first person project, our whole origin was to say, hey, how do we solve proof of personhood now that AI has made it so important, as we put it, has poured gas on the fire of this problem. And but as we got it out there and working with leaders in AI infrastructure like Wenjing, they said, well, actually, there's a second. You're laying the foundation for a critical problem with AI agents, which is how do you prove that an AI agent is acting on behalf of you as a real person? This has since been called agenthood, and I use that term in one slide, so I'm telling you that now. We're here at LFDT because it's now the umbrella project that Trust over IP is part of. But this also pieces of this are ongoing at DIF in terms of the DID methods, and Open Wallet, as you just heard, in terms of the code base for TSP and potentially other pieces of open source pieces of the project as we move forward. And if you're really interested in this topic, scan this QR code and get the 86-page white paper from the first person project, and it will cover these 10 topics. I'm going to give you the just super short relevant version of this for you as an audience today. Just cover like 2 or 3 of these very quickly. So start with proof of personhood. Proving you're a real person online, if you use a global biometric database, it's a relatively tractable problem if you can scale that database. But the issue is, one, if anything that would touch that is privacy. So our goal with the first person project was to solve that problem without using a global biometric database or biometric index of any kind. There are just far too many. It's not just privacy issues, but data control, authority issues. It just gets extremely sticky when you want to try and do that. When the World or WorldCoin folks went to Vitalik Buterin to ask for his endorsement when they launched in 2023, he wrote a very excellent essay. There's a link there to it if you care to, but it's summarized in this chart at the end. He said, these are the 4 things you're after, and WorldCoin is this final column, a specialized biometric, and it scores reasonably. But his preferred solution is social graph based, except these 2 areas. In privacy and accessibility scalability, he felt this was challenging for a social graph based solution. The decentralized solution was good, security was good, but it was challenging there. Well, he was looking at it through a blockchain lens. And when you say, oh, how would we do this with decentralized identity, with VIDs or DIDs and VCs, we actually can hit all four of these, as this slide summarized. We can provide a strong privacy, great decentralization, make it accessible to anyone who's connected to the social graph any place, and do it with strong security. So this concept of, oh, there's a different approach, which we now just call a decentralized trust graph, became the basis for starting the first person project. And also, as I'll describe at the end, the new working group we've started at Trust European Diff of that name. So I'm quickly going to explain. So how does this work? What are these trust tasks that we need to do on top of the trust management protocol? And of course, Wenjing already covered this. The whole reason for Trust OIP is this 4-layer stack that also incorporates governance, and governance plays a key role in the first person project and in these credentials we're going to talk about. As Wenjing covered, it's the 4 layers of the Trust OIP stack are modeled after TCP/IP and the spanning protocol, which is TSP. I repeat all that because it's really important to understand that what makes that work, just as TCP/IP, it was the IP address. With TSP, it is the cryptographically verifiable identifier. And as I said in the comments, we use VID because we mean any type. DIDs are the best known decentralized identifiers. Spent 7 years of my life getting that all the way through W3C, but they're not the only kind that can ever happen. So that's why we use the term VID. And I am going to put in a promotion as a brief promotion as Wenjing did for DID-SCID. It is the meta method for using any format of a self-certifying identifier, because they're the most portable and most user-controlled of those. That was support did WebVH, did carry, and there's several other SCID-based methods. If you're interested in that, please visit our did SCID task force, and that's a link to the page on the TrustRP wiki for this spec. Now, the key point that sets up what we're doing with the first person project is this separation between the cryptographic trust you can achieve at Trust OIP layer 2 with TSP, right? You can achieve that authenticity and confidentiality and metadata privacy that Wenjing explained, and you can give that to any of the actors, be they humans or organizations or agents or whatever else is communicating. But that does not address the human trust layer. You connect and have a verifiable connection with another endpoint, but who or what is actually communicating there? That's what you need various trust task protocols. And the two that we expect to be used the most for that are verifiable credential exchange and trust registry queries. And I'm not really going to talk much about trust registries. We have a trust registry working group on that, the trust registry task force and the trust registry query protocol. Easy to look that up, and that we will have a talk about that at the Trust OIP symposium coming up on the 19th and 20th. I'm just going to talk about verifiable credentials. Probably everyone on the webinar is familiar with this, the trust triangle, the upper half, or the governance diamond of the whole thing, and the critical role of the digital wallet of the holder of the credential. And I just bring this up because everything we're doing with first-person credentials are standard verifiable credentials, with VIDs or DIDs. The last point I want to make here is, with the first person project, because we sort of are crossing the boundary between identity and value exchange and things that agents will do on behalf of individuals, I like to use this to point out that cryptocurrency wallets and identity wallets have a lot of similarities. They're just being used for different purposes. We believe they're going to be coming together. So when I talk about the digital wallet you use with first person credentials, it can perform functions on both sides of this. And now I'm going to quickly cover, just keeping an eye on time, that what is the decentralized trust graph? It consists of it is essentially a decentralized graph that consists of two types of credentials: personhood credentials and verifiable relationship credentials. Personal credentials are the ones, I highly recommend this 63-page paper, 32 authors. You can see all of the affiliations here. It really, sort of changed the game when it came to how are we going to solve proof of personhood without global biometric database. It really boils down to these two things and even just the executive summary really makes these points. Personal credentials through governance are come from issuers who agree they can issue one per live person, and that's per unique person in their own ecosystem or trust community. Could be anywhere from, a school or a neighborhood, a town, all the way up to a nation state. Whatever entity needs to identify individual real people, and it turns out almost those use cases are everywhere, whether it's governments or corporations or universities or professional associations. They all do this anyway. So there should be a very large supply once we get this flywheel going. And the second requirement is unlinkable pseudonymity. That same requirement the UDI European Digital Identity Wallet has. If you have these credentials, and you should be able to assert them anywhere and not be correlated on using them. And the paper says we need ZKP for that. And so with personal credentials, you end up within, as I said, whatever ecosystem you're talking about, they will provide that strong link to a person and a unique person in that scope. It doesn't mean global, and that means you're going to be able to get personal credentials from multiple issuers. But the more of them you have, the stronger the trust that you are a real person. But personal credentials, as described in that paper, doesn't tap into the richness of person-to-person relationships or other kinds of peer-to-peer relationships. And for that, we have verifiable relationship credentials. And the best description we've ever had of these comes from what Jim Zemlin presented at the conference. He said, this is the modern version of the PGP key signing party. And I'm going to quickly summarize this in 2 slides. The part 1, we've got Alice and Bob here with their, we call it an agent wallet because it's the agent does the actions and the wallet actually stores the associated keys and DID docs and ultimately credentials. Here is the same thing Alice and Bob would do if they were, connecting via QR code on LinkedIn or Signal or, Telegram or WhatsApp. It's the same process, only they're not connecting on a network. They are when Alice presents a QR code and Bob says yes, he wants it. He generates a key pair. This is assuming the DID SKID approach and sends the associated DID doc to Alice. Alice verifies it and does the same thing for Bob. This sets up what in the first person project we call a personal private channel, which can be used for many different things. We're going to show you several uses for it, but once that's in place, everything Wenjing talked about is going to be possible, and we'll get to the agents thing at the end. So that exchange of the personal private channel is the pink part at the top. Now, this next step of verifiable relationship credentials is Bob then says, okay, I'm going to take that the pairwise anonymous DIDs, add a date stamp, and I'm going to sign it. And I'll get to the personas thing in a minute. And I'm going to issue that credential to Alice. Alice is going to verify it, and again do the same thing in reverse back to Bob. The DID pair is the same in both, but each of them have signed it with their private key. This is what give Bob and Alice now proof that they have a verifiable relationship in both directions. Now, the material in this, everything that's being exchanged is just cryptographic material. There's no human human readable and relatable information in this. So I'm not going to cover it today, but the next step in using this personal private channel is what we call R card exchange, relationship card exchange. Those are essentially the digital business cards or whatever information Alice and Bob want to exchange now over that channel that they can both remember and use. It's essentially the modern relationship-based address book. But I'm not covering that here today. I'm just going to say from a trust standpoint, now we have the complete, what we call verifiable relationship trust triangle. Bob and Alice can each prove that they're unique in one ecosystem, and then they can prove with the proper ZKP, prove they have a unique relationship in that ecosystem. So the basic idea of the proofs of the first person project is the more personal credentials you have and the more unique relationships you can prove in the ecosystems you're part of, the stronger that the stronger the trust that you are a unique and real person in whatever ecosystem. And if you're doing it with ZKP, you're not having to reveal the specific ecosystems or relationships that are involved. So that's the essence of it. I'm just keeping an eye on time here. I will make two final points to tie this into personal agents. And now I'm going to talk about personas, which is really one of the most important parts of the whole thing. Because these are pairwise DIDs, they don't really, Bob and Alice can't prove to other parties that they are Bob and Alice. So they share their choice in each case of additional DIDs that we call persona DIDs. So that bottom blue box is the pairwise relationship DIDs that are generated automatically. For Bob and Alice to assert a persona, and we show three groupings just to describe how persona DIDs can work. They're not definitive. Obviously, you're going to have public personas, but these public personas being a DID can be pseudonymous. Think an artist like Banksy, right? He could actually digitally verify his works and still be pseudonymous. They can be community personas, such as a persona that a developer wants to have in a specific project, like the Linux kernel, or across all their projects at Linux Foundation, or across all open source. They can have an open source persona, but they can have a different persona for, say, their political activity or their their schoolwork, whatever it is. And then even private personas make a lot of sense here when you think about medical records, legal signatures, or whistleblowers. They need to prove they are the same person across multiple trust communities or ecosystems, but they don't want that correlated anyplace else. With this architecture and proof of personhood, we can now solve that problem at scale and restore a privacy that really hasn't been possible on the internet in quite a while. Now, the very last point I'll make before we go into questions is, what does all this mean to agenthood? Besides just proving the person is the person, and I have exactly one slide to show you, because everything that I just talked about in terms of verifiable relationships can be applied to your relationship with an agent. This is the same slide, just with an agent, and even the potential that if that agent is doing multiple things for you, it can track that by having its own set of personas that are associated with particular kinds of events or behaviors that agent might have. Now, obviously, if you have specialized agents, then they just have one persona and they're performing whatever functions there are. But the overall rule here is agents should have identity and credentials just like people do, or just like organizations do. And if we treat them that way and we use things like, on top of TSP, we can build a very strong, very resilient trust fabric that includes agents and the proof that they are acting, in this case, on Alice's behalf, without having to create a whole separate system for doing that. And I am done. I get a brief pitch here for this new working group at Trust over IP and DIF. And these are a couple examples of the task forces that we're starting. We organize our work in working groups and task forces. And if you're interested in that, scan this QR code. I'll also put the link to these slides in there. And that's all I have, Jessica, so we can go over to questions.
Thank you so much, Drummond. And yes, we do have few comments posted recently. I believe there's one here. Do we have a POV on root PHC credentials? People often cite government issued credentials, and credentials are often layered.
All right. I showed a couple more QR codes, but I'm going to see the question.
Yeah. And then
Okay,
there's
I'm looking at
two
it. It
others.
helps do we have a point of view on root PHC credentials? So yes, I want to say we have a neutral point of view, which is government issued credentials are definitely, I said, well, I want to put a proviso, depending on the government. In general, I would say those are good credentials. And at Internet Identity Workshop 3 weeks ago, we had great discussions about the new state endorsed digital identity credentials coming from Utah and hopefully spreading to other US states. Those are ideal PHC credentials. The European PID, personal identity credential for the EU Digital Wallets Initiative, should also be very good. That's what I'm over here in Europe I've been meeting with people about. And as long as they are privacy preserving themselves, they will make great PHC credentials. But I want to point out they're not the only source. Linux Foundation, for instance, should be able to issue personal credentials to its community or any individual project to its community. So there are many other potential sources. Every company or corporation that maintains that issues employee credentials should also be able to do that.
So, if I may add to my question, Drummond, so if you look at an employment credential, for example, employment is based upon verifying your identity in different ways, right? It's not like they just like you, so they're going to hire you. So they're going to look at your government issued credentials, your work experience, a whole host of different things before they issue. So it's always layered, right? So, for example, if LFDT decides to issue credentials for all members, I'm sure LFDT will have to look at some stuff before they are confident in issuing those credentials. So that is always a question that arises in some of those conversations where, what do you call, what would a root credential look like? That's where that question came from.
It's a great point. And so again, I've mentioned governance several times. With the first person project, we've said the importance, you only will actually have a solution if you have governance over a network of issuers of personhood credentials. We call that network, surprise, surprise, the first person network. And we have formed to govern that. We ended out after a year's worth of contemplation with a cooperative. And we established the first person cooperative right before IIW, and we are starting to develop governance for it. If you're interested in that, by all means, join the first person mailing list. I'll put the link in the chat. But that is literally the governance half of that. There's a bunch of SSI folks that have leaned in. Wendy Seltzer, the former lead counsel for W3C, is helping to lead that among other people. So yeah, that is super important. Whether a company is good enough at doing the identity proofing for those credentials is going to be part, Sabala, of what we have to look at.
If I may add one more thing about the layered thing, credentials are never sort of one credential that answer all questions. You will always have many different credentials, and it really is application flow. So what the TSP designed to do is allow you to do credential checking in any part of your application, which means that once you get into you may be using very different credentials in Access and Web, but when you get to payment, you will use different credentials. And that is what we provide is a dynamic way for applications to build on that.
Thank you.
One very quick, if we have some time, can you speak on the advantages of FPP might have over the other available credential protocols?
Oh, I don't want to imply that we're trying to create a new credential protocol. We are with first person project is focused on defining two protocols in the two credentials and the governance around them. It actually also, because of the ZKP requirement, says there's a set of wallet requirements. but the credential protocols can, ideally are the same protocols you would use to issue other types of credentials. Again, with that ZKP asterisk, because there are ZKP-based credential issuance and presentation protocols like a non-creds today. And there is very active work on that. Again, I just left some meetings here today in Sweden on that very project. Because again, the EU digital identity wallets, it's not going to support ZKP at the outset or ZKB-based credentials at the outset, but there's a strong sense that it has to get there, and there's a lot of folks working on that. So we are working with them because we know we have to have it. Again, you can I'll put a link. I put links to various things. I had QR codes in the chat. I'm going to add one for that paper. It's very, very well known.
Thank you, Drummond. And sorry that we are over 2 minutes, but I really appreciate everybody's attendance. And yeah, feel free to look at the links that are posted in the chat. And thank you, Drummond. Thank you, Wenjing. And we will see you next time.
Thank you.
Yeah, I just put a link to the personal credentials paper in there. You can also you can just put personal credentials in almost any browser, and there are a lot of links to that paper, so you go right to it. Super, really, really happy, and thank you to LFDT for hosting all of this work, both Trust ToIP and everything we're doing, and the work to adopt this within the Linux Foundation. This is great.
Thank you so much. It is our pleasure. See you next time, guys. Thank you.
Thanks all. You bet.
Bye.
Bye-bye.